In the world of paleontology, surprises are always waiting to be unearthed. Deep in Mongolia's Gobi Desert, a team of scientists made an extraordinary find. They uncovered a fossil hailed as one of the cutest dinosaurs ever discovered. This tiny creature was barely the size of a modern-day hummingbird. The fossil was remarkably well preserved, allowing detailed study. It lived about 99 million years ago during the Cretaceous period. The discovery was made by a team led by Dr. Xing Lida from the China University of Geosciences. They were conducting a routine excavation in the Gobi Desert, known for its rich fossil deposits. The fossil was embedded in amber, preserving it in exquisite detail for millions of years. The news spread quickly through the scientific community. Paleontologists worldwide were eager to study this remarkable specimen. It promised to shed new light on dinosaur evolution, particularly how some evolved into birds. The fossil's small bird-like features blurred the line between dinosaurs and modern birds. This discovery captivated imaginations and opened new avenues for research. When we think of dinosaurs, we often picture massive, fearsome creatures, but this new discovery challenges those perceptions. This dinosaur was tiny, delicate, and undeniably adorable. Its skull was less than 2 centimeters long, making it seem less threatening and more appealing. The fossil shows a creature with large, round eyes, giving it an almost cartoon-like appearance. Its beak was small and pointed, perfect for catching insects. The dinosaur's body was covered in feathers, more like fuzzy down than flight feathers. Imagine a tiny feathered ball with big eyes and a tiny beak. Hard not to find endearing. The fossil even preserved the dinosaur's tiny feet, showing delicate toes perfect for perching on branches. Scientists believe it was probably very active, flitting from branch to branch, catching insects. This image of a tiny, energetic creature adds to its appeal. It's easy to imagine it as a prehistoric equivalent of a hummingbird or a small songbird. This combination of tiny size, appealing features, and lively behavior makes it, in many eyes, the cutest dinosaur ever discovered. The discovery challenges our perceptions and expands our understanding of dinosaur diversity. It shows that dinosaurs came in all shapes and sizes, some of them undeniably charming. The process of discovering and studying this fossil was painstaking. It began with fieldwork in the Gobi Desert, known for its rich fossil deposits. The amber containing the fossil was initially small and unassuming, but the sharp eyes of the paleontologists spotted something unusual. They could see a tiny shape preserved inside the amber. At first, they weren't sure what it was, but closer examination revealed something extraordinary. The amber was carefully extracted from the surrounding rock and taken to a laboratory for further study. Advanced CT scanning technology allowed scientists to see inside the amber without damaging it. The scans revealed intricate details of the tiny skeleton inside. Every bone and feather was visible in stunning detail. The next step was to analyze the data from the scans, creating three-dimensional models of the skeleton. These models allowed scientists to study the dinosaur's anatomy in great detail. This process took many months of careful work, but it was worth it. The results revealed a creature unlike any dinosaur discovered before. It was a new species, possibly even a new family of dinosaurs, ready to be shared with the world. Let's take a closer look at this remarkable little dinosaur. Its scientific name is Oculudentavis kaungrai, meaning eye-tooth bird in Latin. Oculudentavis was incredibly small, with a skull only about 14 millimeters long. Its most striking feature was its large, bulging eyes, taking up much of its skull. The eyes faced sideways, giving the dinosaur excellent peripheral vision. The dinosaur's beak was small and pointed, containing about 30 sharp teeth, suggesting it was an insectivore. Its skull was fused, like that of modern birds, giving it extra strength. The fossil also preserved some of the dinosaur's neck vertebrae, showing a flexible neck. The creature's body was covered in feathers, more like fuzzy down than flight feathers. One of the most interesting features of Oculudentavis was its feet, adapted for perching on branches. This, combined with its small size and insectivorous diet, paints a picture of a creature that lived in trees. It probably hopped from branch to branch catching insects. In many ways, it behaved more like a modern bird than what we typically think of as a dinosaur. This discovery provides valuable insights into the diversity and evolution of small, bird-like dinosaurs. Oculudentavis challenges our understanding of what dinosaurs looked like and how they lived. What makes this fossil truly unique is not just its size, but the exceptional quality of its preservation. The amber in which it was found acted as a perfect time capsule, preserving details often lost in other types of fossilization. This gives us an unprecedented look at a dinosaur from 99 million years ago. Every tiny bone, every delicate feather is visible in stunning detail. One of the most remarkable features is the preservation of soft tissue. In most fossils, only bones remain, but here we can see the dinosaur's tongue and even its eyelids. The amber also preserved the dinosaur's feathers, giving us valuable information about the evolution of feathers in dinosaurs. The fossil also preserved the dinosaur's sclerotic ring, a ring of bones that supports the eye. In Oculodentavis, this ring is spoon-shaped, suggesting a unique type of vision. The shape of the eye bones indicates that the dinosaur was probably active during the day and may have had excellent color vision. Another unique feature is the dinosaur's teeth, fused directly to the jawbone, unlike other toothed birds or dinosaurs. This is another indication of just how unique this little creature was. All these features combine to make this fossil one of the most informative dinosaur discoveries in recent years. The exceptional preservation allows scientists to study features rarely seen in dinosaur fossils, providing new insights into prehistoric life. Comparing Oculodentavis to other known dinosaurs highlights its uniqueness. Most familiar dinosaurs were much larger. Even Compsognathus was chicken-sized. Oculodentavis was closer in size to a hummingbird. It shows a mix of dinosaur and bird-like characteristics. Its toothed beak is reminiscent of Archaeopteryx. This combination of features doesn't fit any known group. Its body plan is more bird-like than most dinosaurs. The diminutive size of Oculodentavis is perhaps its most striking feature. When we think of dinosaurs, we often imagine giant creatures that dominated the landscape. But this tiny dinosaur shows us a different side of dinosaur diversity. It's believed to be the smallest dinosaur ever discovered. This raises interesting questions about the limits of dinosaur size and the diversity of dinosaur species. The skull of Oculodentavis is only about 14 millimeters long, smaller than any known dinosaur or bird. Based on this, scientists estimate that the entire animal was probably no larger than the smallest hummingbird alive today. This extreme small size would have had significant implications for the dinosaur's lifestyle and biology. Smaller animals have faster metabolisms and need to eat more frequently relative to their body size. Being so small would have allowed Oculodentavis to exploit ecological niches unavailable to larger dinosaurs. It could have lived in dense forests, hopping between small branches that couldn't support larger animals. Its small size might have also helped it avoid predators, making it a quick-moving target difficult to catch. The discovery of such a small dinosaur raises questions about how small dinosaurs could get, and whether there are even smaller species waiting to be discovered. The discovery of Oculodentavis highlights the crucial importance of fossil records in our understanding of prehistoric life. Fossils are our window into the past, providing tangible evidence of animals that lived millions of years ago. Each new fossil discovery has the potential to change our understanding of prehistoric life. The Oculodentavis fossil is a perfect example of this, challenging many of our preconceptions about dinosaurs. Fossil records help us piece together the story of life on Earth, showing us how species evolved over time. They reveal the diversity of life in different periods of Earth's history. Without fossils, we would know very little about dinosaurs or any prehistoric life. Each fossil is like a piece of a giant puzzle. The more pieces we have, the clearer the picture becomes. But the puzzle is far from complete, and new discoveries like Oculodentavis show us how much we still have to learn. Fossils also help us understand past environments and climates, providing valuable information about ancient ecosystems. Moreover, fossil records are crucial for understanding extinction events and the resilience of life on Earth. They show us which species survived major environmental changes and which didn't, offering insights as we face current environmental challenges. The study of fossils, known as paleontology, is not just about understanding the past, but also about gaining insights that can help us navigate the future. Each new fossil discovery, like Oculodentavis, adds to this valuable body of knowledge. The discovery of Oculodentavis has significant implications for our understanding of dinosaur evolution. It shows us that dinosaurs came in a much wider range of sizes than we previously thought. Dinosaurs could be as small as modern hummingbirds. The bird-like features provide new insights into the evolution of birds from dinosaurs. This fossil shows bird-like characteristics at a much earlier stage. It suggests that the evolution of bird-like features was not a simple, linear process. Different lineages may have independently evolved bird-like traits. This complicates our understanding of the dinosaur-bird transition. The unique features challenge our existing classification systems. It suggests there may have been many more diverse lineages of small bird-like dinosaurs. Many of these may still be waiting to be discovered. Amber fossils can preserve details lost in other types of fossilization. The exceptional preservation of Oculudon tavis allowed scientists to study features rarely seen in dinosaur fossils. As more amber fossils are discovered, we may gain even more detailed insights into dinosaur diversity and evolution.